Bismillahirrahmanirrahim. So, okay, I got this extension worksheet regarding acids and alkalis, and this is from the same website from where we get those answers of the end of chapter, and as well as your further questions. The answers of further questions are, and also the end of chapter questions are in on a website. Okay, I hope you guys know the link to that website, and from there I got these extension sheets. You can get all those extension sheets directly from those websites, and the worksheets that Wajiha, you just shared in the group, those most of them are extension sheets from the same website. But yes, they have not explained it. The answers to these questions to these extension sheets are not there. So let's discuss this extension sheet. This is regarding neutralization, right? Methods to follow the course of a neutralization reaction. How can you follow the course of a neutralization reaction? What do you mean by that? Meaning that, you know, how much of a neutralization has taken place, whether it is complete or not, and if it is not complete, how much of it has already taken place? What are the different methods by which we can find that out? Now, in our experiments and the, you know, whatever we have studied so far, how do we make sure that all the acid has reacted? How do we make sure that all the acid has reacted? You know, in the methods that we have studied so far. Okay, universal indicator is one way. Yes, that's a good answer, Hassan. And universal indicator is used when? What is the other way? Okay, what are the other ways? One is universal indicator. What are the other ways of finding out that all the acid has reacted? Come on. Okay, yes, that's another way. Wajiha, good job. If there is any gaseous product, if there is any gas being produced, whether hydrogen or carbon dioxide, hydrogen in the case of acid reacting with metals, and carbon dioxide in case of acids reacting with carbonate, then we can follow the fizzing. If when the fizzing stops, that means neutralization has completed. Okay, any other? So Riaz, to check if solution is acid or alkaline is the same as using an indicator. Like, how would you check if the solution is acid or alkaline? By using an indicator, right? So that is the same thing. Okay, can you guys read each other's answers? Yes, Wajiha. Okay, good. Okay, yes, Wajiha. That answer is the correct answer. If we are using a base is, what's a base? You can even raise your hand if you want me to unmute you. What's a base? Insoluble alkali. Good job, Wajiha. So if we have a base, of course, it's insoluble and then it will settle at the bottom. It's settling at the bottom shows us that it has stopped reacting, and whatever had to react has already reacted, and now this is left over. So yeah, these are the three ways I would say. One is indicator, when both the reactants that we are using are soluble and there is no gaseous product, there is no precipitate being formed. So we don't, I mean, precipitate might be formed, but when both the reactants are soluble, so how would we know that the reaction has stopped? So indicator is one way. Second is to observe the bubbles, when the bubbles will stop forming, whether hydrogen or carbon dioxide. And the third is to use a base, okay? Because base is insoluble. When it will stop reacting, because it does not dissolve, it will settle at the bottom. Yes, of course, nothing is without water. All the reactions require water. So other than these methods that we already know, okay, these are additional methods that we are going to study now. One is the same. First one is the same, universal indicator. Okay, this you already know. Second is using a pH meter. Now, pH meter again works the same way as an indicator. The only difference is that it has calibration. Calibration meaning that it has markings on it which give us an exact measurement of the pH. So a pH meter, I will read this. A pH meter can give a more accurate measure of pH than universal indicator paper. You can also use pH sensors linked to a data logger or computer. A graph can then be produced from data gathered to show how the pH changes as alkali is gradually added to acid. Okay, so the question is, why do you think universal indicator just gives us an approximate value for the pH of a solution and pH meter is more accurate? Why do you think the pH meter is more accurate? Yes? Why do you think the pH meter is more accurate rather than universal indicator? Any ideas? Because the pH meter has calibrations. I hope you guys know the meaning of calibration. Like, you know, there's a scale. There's a scale made on it and it is digital. That makes it even more sensitive because when we are using current, it becomes more immediate and it becomes more accurate. So if we are using pH sensors or pH meters, we are using scales. Now scales have graduated scale on them, and so we can use those graduated scales, so it gives us the exact value of the pH. Now, why is the universal indicator not that accurate? Because if you look at the universal indicator picture given in your book, there is no scale, right? Because you see, look at the page, or maybe I can show you the video. Yeah, if you look at this universal indicator, there's a range. Can you see there's a range? So if the pH is somewhere here or here, both the solutions will have the same red color. So this is an approximate value. This is only an approximate value. Yeah, in pH meter, we have scales, we have really small divisions, so we know exactly what the pH of the solution is. Like if, for example, some solution has this pH and the other solution has this pH. Now, both of them have different pHs, but they both will show the same color in the universal indicator. And so we would not be able to differentiate between these two solutions, whereas this solution is more acidic than this one, right? So that makes this universal indicator just an approximate, this universal indicator is just an approximation, right? Okay, then yes, back to my screen. So this can be connected to a computer and then we can have this graph. Now let's talk about this graph a little bit. Now initially you had some alkali. Initially you had some acid, right? The x-axis is the volume of alkali and you have some acid already in a beaker, and now you're adding alkali gradually. Now as you are adding alkali, you can see that the pH does not increase. I mean, it is increasing, but the increase is very gradual. The increase of the pH is very gradual. Why is that? Why is the pH increase gradual in the initial, when the volume of alkali which is being added is still less? I mean, it is still small. You have added only a small volume of alkali. So for the initial values of alkali added, the increase in pH is less. That's because not all, because you know the, okay, again I will show my, yeah, yes, okay, good job Vajiha, because we are adding slowly. Yes, we are adding slowly, as well as, see, when we are adding alkali, first of all, yes, we are adding slowly, and then the pH rise will take place only when there is an increase in the concentration of this, okay, and a decrease in the concentration of this. So the pH will rise when this increases and this decreases, right? And this will only take place when there is an abundant amount of hydroxide ions reacting with enough hydrogen ions to give us the neutral water molecules. When we have now again, going back to my picture, going back to that thing, can you see exactly, I don't know what this volume of alkali is, but in the middle of the graph, you can see there is a vertical rise. There is a vertical rise in the pH. Now that shows that's when the neutralization reaction has completed. That's when the neutralization reaction has completed. Okay, and so the pH has risen dramatically. Why? Because now no more hydrogen ions left to react with the hydroxide ions to give you the neutral. For example, I'm again showing my video. These are lots and lots of hydrogen ions present in the beaker. Now I am adding alkali gradually. Okay, this will react with this to form water. Now the hydroxide ion concentration is not rising because this is reacting with this. The hydroxide ion concentration would not rise. I'm further adding, so more hydroxide ions are reacting with it. So yes, the hydrogen ion concentration is decreasing very gradually, but the hydroxide ion concentration is not increasing because they are all getting used up. They're all reacting with the hydrogen ions to form water. And therefore, there is a gradual rise in pH because of the decrease in the concentration of hydrogen ion, but the pH is not rising too dramatically. But when all of them have reacted, and all of them have formed water, now if I keep, now all the hydrogen ions have reacted, right? Now if I keep adding hydroxide, now there are no hydrogen ions to react with this. So dramatically the pH rises. Dramatically the pH rises as is shown in the graph. Okay. And then you have lots and lots of water. So let's go back to that picture. And then, so this dramatic rise in pH all the way till 14 is because now you are adding hydroxide ions and there are no hydrogen ions to neutralize those hydroxide ions. So the pH rises too high. Do you understand? Did you understand? So there are not many hydrogen ions reacting with the hydroxide because all the hydrogen ions have already been used up. So this shows that the neutralization reaction has been completed. So this is how the shape of the pH graph for any neutralization reaction would look like. Okay, initially there is gradual increase in pH as the hydrogen ions are reacting with the hydroxide ions. Once all the hydrogen ions have been used up, all the hydroxide ions have reacted with the hydrogen ions, and now you're further increasing the volume, you're further adding the alkali, you're further adding hydroxide ions. Then those hydroxide ions do not have any hydrogen ions left over to react with them. Therefore, they will dramatically increase the pH to 14. And then there is a limit, of course, and then you don't get any pH above 14. 14 is the limit. So at 14, the graph flattens out. You don't have the pH scale stops at the value of 14. So did you understand the pH curve? Did you understand the pH curve? Yes, okay. Was it taking time to react was taking time to react with hydrogen, or was because we are adding slowly? Yeah, we are adding slowly. We are adding slowly because remember, we have to make sure that the amount of acid and alkali are exact. We cannot go in excess. So we have to be careful. We have to add only that amount of alkali which will exactly neutralize the hydrogen ions, and then gradually, because we have to plot a graph. Okay, and we have to note down the time when neutralization has exactly stopped. Okay, and when exactly at which concentration did the pH dramatically rose up. So if I give you this graph and I ask you where exactly at which point has neutralization reaction completed, at which point exactly on this graph has neutralization reaction completed, which point would you say? And you can even raise your hand if you think you cannot type. You can raise your hand and I will unmute you. So on this graph, at which point do you think, let me, 13.5, the graph does not give you any value. The graph does not give you any value, 13.5. I'm saying in the graph. So x-axis, okay, I'm sharing my video. I will show you the graph. Can you hold this? This is the volume of alkali, right? That we are adding in cm cube, and this is the pH, right? And the shape of the graph is like this, right? So where exactly in this graph will you say that neutralization reaction has completed? You know, when here, when the graph becomes absolutely vertical. You know why? You know why? Because now there are no hydrogen ions left for hydroxide ions to react with. And so whatever you're adding is shooting the pH up. So this is where the hydrogen ions have finished. This is where the hydrogen ions have finished. No more hydrogen ions. So when you're adding alkali, you're just increasing the hydroxide ion concentration. The pH is shooting up. Okay, so that's how. So here, at this point of the graph, you know that neutralization has completely, yes, Hassan, yes, where the graph is vertical and straight. So this is our neutralization point at this point of the graph, okay? Now, let's move on. Okay, let's move on. Now, this was pH, right? This is how you find out where the neutralization reaction has completed, by looking at the graph or by following the pH. The other is using heat change. Heat change. I don't know if you have done exothermic or endothermic reactions. Okay, but if you have not done, I will just tell you that all the reactions require energy to take place, and they also give out energy. Okay, why and how, that all will be discussed in detail when you will do the thermal chemistry, when you will do that chapter of exothermic and endothermic reactions. Okay, so the what they are saying is that neutralization is an exothermic reaction, meaning heat is released. Heat is released. Now, all the reactions take in energy and give out energy. But the thing is, what do they do more? Do they take in more or do they give out more? If they give out more, we call that reaction exothermic. If they take in more, then we call those reactions endothermic reactions. So neutralization is an exothermic reaction, meaning that it gives out more heat than it takes in. It gives out more heat than it takes in. So I'm reading this. Neutralization is an exothermic reaction. It gives out heat. You can measure the temperature rise when different amounts of acids are added to an alkali. So when you are adding alkali, more and more molecules of alkali are reacting with the molecules of acids. And as they are reacting, heat is getting released. So by measuring the temperature, by using a thermometer, we can find out when the reaction is the most. The reaction would be the most when the heat produced is the most, because that would show that all the acid molecules are reacting with all the alkalis, and that's how most heat is being produced. And we measure that with the help of a thermometer. The maximum rise should be when just the right amount has been added to form a neutral solution. Did you understand this? And I will talk about a graph. So again, in this case, we make a graph of the volume of alkali added against the temperature. The volume of alkali against the temperature. Okay, so did you understand? So I will repeat this. How do we use heat change to follow a neutralization reaction? Because the heat given out in a neutralization reaction is greater than heat taken in, therefore, we measure the temperature with the help of a thermometer to find out when the neutralization reaction has completed. So when the temperature is maximum, we know that all the molecules of acids have reacted with all the molecule of the alkali to release maximum heat and therefore the maximum temperature to form the neutral solution, right? See, this is question number 3. Sketch a graph to show how you would expect the temperature of an alkaline solution to change as acid is added until it is well in excess. That is beyond the point of neutralization. What do you think would be the shape of the graph? What do you think would be the shape of the graph? Maximum temperature depends upon how much energy is being released by the reaction. So the stronger acids and alkalis will produce more heat. Weak acids and alkalis will produce less heat. So stronger the reaction, more the heat is produced. That is why, remember, I told you that when the reactants are highly strong, when the acid is highly strong, you have to be careful. Why? Because a lot of heat is being produced and that heat itself can cause burn, right? So that is why, if you remember. So any ideas about how the graph of the volume of alkali against temperature would look like? You can even show me your screen if you can want to draw and you want me to see your graph. Yeah, when the line is vertical. Yes, I am recording my class. You can listen to the recording, okay? And please use your real name, Hassan. I know you like trains, but okay. So, okay, let me share the graph, okay? I got the graph for you. Let me get that graph. What happened? Okay. Here. This is how the graph would look like of temperature against the volume of acid. Now you can have the x-axis could be the volume of acid. It could be even the volume of alkali. It could be either volume of acid or volume of alkali. It doesn't matter, right? Whatever you are adding. So one of the two things you will already have in a measured, I mean, you will have the measured volume already in a flask or a beaker. And then the other, a reactant, for example, if you have acid already, if for example, you have alkali already, for example, 25 cm cube of alkali in a beaker, and then you are gradually adding acid, right? So now you will plot the graph of the volume of acid. You will add it gradually, 1 cm cube at a time against the rise in temperature. So this is how the graph looks like. So what does this graph tell us? That as we are adding acid, more and more molecules of acid are available to react with the alkali, which is already in the beaker. And as the molecules are reacting, energy is being released, right? And that energy is increasing the temperature, okay? And so the rise in temperature is straight line. That's a linear rise in temperature, increase in temperature. So much so that it reaches its peak, which is almost, what is it, 42.5 or 43 maybe, yeah, 43 degrees Celsius, almost and then the temperature is decreasing. Can anybody guess why the temperature is decreasing as we are adding the volume of acid? We are still increasing the volume of acid, but now the temperature is decreasing. Use your common sense. Yes. My voice is echoing a lot. Yes, Wajiha, good job. There is no more hydrogen. I hope you don't have two devices logged in at the same place. If you have, remove the other device, or that device should be far away from you. Yes, Wajiha, good job. Very good, Wajiha. There is no more hydrogen ions left behind. No more hydroxide ions. No more because in this particular case, we are adding the acid, right? We are adding acid. So no more hydroxide ions, you mean to say, right? You wanted to say no more hydroxide ions because hydrogen ions we are adding. Did you get me, Wajiha and Hassan? Yes, yes. I am again using my yes. So you are adding this. You are adding this. So you already have, let's suppose you have 5 ions. I'm just, this is only for your understanding. For example, you had 5 ions available in the beaker. Okay, now you're adding hydrogen ions. So when you added hydrogen ion, this reacted, gave water, this hydrogen ion reacted, gave water, and so on and so forth. So you needed exactly 5 hydrogen ions. So this is when the temperature was increasing. This is as they were reacting, forming water molecules, heat was being released, right? Heat was being released. Now, all the hydroxide ions have been used up because you have hydroxide. You're not adding any more hydroxide. You're adding acid. That means you're adding hydrogen ions. So now if you will add more hydrogen ions, there are no hydroxide ions left to react with, and so no more temperature released. In fact, the heat is being lost to the surroundings by conduction, convection, radiation, and so the temperature is going down because no more new heat being released. So whatever the heat there was, it is being lost to the surroundings. Okay, good job, Hassan. So this is another, this is another graph, okay? Temperature against the volume of acid added. It can be the amount, it can even be the volume of alkali, okay? No need to get confused. Okay, now, where did that go? Okay, let me, where was I? Yes. Okay, let's move on. Now, what's the fourth way of following a neutralization reaction? By using a conductivity meter. By using a conductivity meter. Now, as the name suggests, we will measure the conductivity of the solution. Now, why are we following the conductivity? Conductivity is due to what is responsible for conductivity of any substance? Who will tell me? What is responsible for conductivity of anything? Water is responsible for conductivity. Yes, mobile charged particles. Mobile charged particles, moving charged particles. If the particles are moving, but they are not charged, there will be no conduction. If they are charged, but they are not moving, then also there will be no conduction. So for conductivity, you need mobile charged particles. Now, in this case, we are dealing with which ions? Hydrogen ions and hydroxide ions giving us water. Now, Wajiha, tap water, because it has ions, will be conducting will be conducting electricity, but pure water, distilled water, won't be able to conduct electricity because these a water molecule is a simple molecule. It is not charged. It is not charged. It is polar, all right, but it is not charged. It does not have complete charges. It is a simple covalent molecule. So pure water is a poor conductor of electricity. It is not a good conductor. So these ions will be responsible for conduction. So let's suppose you had a known volume of alkali. So let's suppose you have 5 ions, 5 hydroxide, just for your understanding, okay, just for the understanding purpose. Now, this alkali has a lot of charged particles in the form of hydroxide ions. So this will conduct electricity quite well because it has these charged particles and they are mobile within the water. But now when you will add acid, that means you're adding hydrogen ions, they will combine together to give water. They will combine together to give this simple covalent molecule, which is a bad conductor. So as you are adding acid, these charged particles are disappearing, getting converted into these simple covalent molecules of water. Therefore, you are decreasing the number of charged particles. You are decreasing the number of charged particles. So conductivity will decrease. Conductivity of the solution will decrease so much so that at the end there is, almost there are no charged particles available. But if you keep adding now hydrogen ions, if you keep adding hydrogen ions, if you keep adding the acid, now what do you think would happen to the conductivity of the solution? What do you think would be happening to the conductivity of the solution? Come on. Yes, yes, Hassan, good job. The conductivity will rise again because, yes, the conductivity will gradually increase as you will keep adding hydrogen ions, because now no hydroxide to react with these hydrogen ions, and therefore they will be available to conduct electricity because they are unreacted and they are in the ionic form. They're in their charged form, and so they will be available. Therefore, the conductivity will rise. Now, let me show you. The graph of conductivity against the volume of acid or the alkali here. This is what happens to the conductance or conductivity. Initially, the conductance will decrease because the hydrogen ions are reacting with the hydroxide ions, turning into covalent simple water molecules. But then the conductivity starts rising. So on this graph, if you are asked to mark that point when all the acids have been reacted with all the hydroxide ion, which point do you think is that on this graph, where the neutralization reaction has been completed, where all the acid molecules have reacted with the hydroxide? From where it rises? Yes, the bottom point, the bottom, the triangular point. Yes, the bottom point. Good job, Wajiha. Good thinking. Okay, what about this temperature, this graph? Where is that point, exact point of neutralization on this graph of temperature against the volume of acid? Of temperature. Where is the point of neutralization on the graph of temperature against not 35, Hassan. It's the peak. It's the top. It's the top part. Okay, it's the top. From where it is dipping down. The top corner of this graph. I hope you got my point, right? The peak. Yes, the top point. Yes, Wajiha and Hassan. Good. Okay. Yes. Okay. Now I hope you understood this. This extension sheet. So using a conductivity meter, neutralization reaction, hydrogen ions from the acid react with hydroxide ions from the alkali and they make molecules of water. So ions are removed from solution. It is ions that carry the charge during electrolysis. As they are moved in neutralization, the conductivity of the solution will decrease to a minimum at the point of neutralization. Okay, now these questions. Question number 2. What apparatus do we use to make small additions of one solution to another solution? What apparatus do we use to make small additions of one solution to another solution? What apparatus do we use to gradually add one solution to another solution? Pipette. See, pipette is used to add known volume. Okay, pipette is used to measure known volume. Yes, Hassan, burette. And spelling of burette, please correct your spelling of burette. Okay, you don't know what pipette is? Can we have it? Do you know where it is? Okay, can you bring it? Okay, I'll show you a pipette. See, pipette is used to take a known volume. For example, how did you get 25 cm cube of, let's suppose, alkali in the conical flask? How did you get 25 cm cube of alkali in the conical flask? With the help of a pipette. So you took 25 cm cube and then you added it directly into the conical flask. But when you do not know how much of the acid do I need to add, like you have to be really careful and you have to add drop by drop. So you're waiting for the indicator's color to change. When you have to add drop by drop, that is when you use burette. Okay, spelling of burette is this. This is the spelling of burette. Yes, this is the one. Can you unscrew it? Unscrew it. I'll show pipette. Okay, you guys have seen it. मुझे नहीं चाहिए transparent, यही वाली ठीक है. It's okay, we don't have time. Okay, this is a pipette. This is a pipette. You must have seen it. You must have seen it at the top of many medicines, especially the ones used, for children. Yes. So there is a rubber bung. I mean, there's this rubber thing. If I will press it, drops will come out. And so I'm not pressing it. See, this is, so I am pressing it. And when I will release it, the medicine will be sucked in. Yeah. And so I will now press it. I'm pressing it. And so it's out. Now in labs, they have this marked, okay, give it to me. So in labs, there are some marks. Yes, there is a mark, for example. In the lab, there is a mark. And so they suck out and they make sure the liquid is till that mark. Till that mark, okay? So that mark can be, 25 cm cube, 50 cm cube. So pipette is used to introduce a known volume. Like, if I want to add 25 cm cube of alkali, then I will use, yeah, this is also called a dropper, by the way. Yes, that's an easier word, layman word for a dropper. Pipette is the same thing. Yeah, pipette is the same thing. Pipette, dropper is the same. This is this is also called a dropper. Okay. Let's move on to the next question. A sketch, okay. Okay, 3 and 4 we have already done. Sketch a graph to show how you would expect the temperature of an alkaline solution to change as acid is added until it is well in excess. That is beyond the point of neutralization. So when it is well in excess, the temperature will go down, right? Because no more reaction going on. Question number 4, explain why the conductivity of an alkaline solution will decrease to a minimum as acid is added and then start to rise again. And we have done this already. If you do not understand any aspect of it, then you are more than welcome to ask me. Okay. Then let's move on to your book's question answers. The book question answers. Mary and Saqib. This one. Is this there in your books? Mary and Saqib. End of chapter, question answers of acids and alkali. Mary and Saqib want to make some crystals of copper sulphate. Okay. They have dilute sulfuric acid and black copper oxide powder. Remember, I asked you in my last class, how can we make copper sulfate? And can we make copper sulfate using copper and sulfuric acid? Can we make copper sulfate using copper and sulfuric acid? No, Hassan, you will use pipette. You will not use dropper. Dropper is a layman term. You will use the word pipette. You don't have this question in your book. Okay, whether you have it or not. So, okay. So no is for that question which I just asked, that copper cannot be used, right? With sulfuric acid to make copper sulfate. Why? Why can't we use copper? No, it's okay. Because of the reactivity series, Hassan, no, you will say that because copper is less reactive than hydrogen. This is how you will say, okay? Because copper is less reactive than hydrogen, so it cannot displace hydrogen out of copper, or out of sulfuric acid, and therefore cannot make. Yes, so this is what you will say, that copper is less reactive than hydrogen, Okay, so we, instead of copper, we use copper oxide, right? So this experiment, by the way, is already given in your book, okay? On this page, I don't know the page number now. Preparing salts, where you have preparing salts, making a salt from an acid and a base. Okay, so part A, describe how they can get copper sulfate crystals safely. How can they get copper sulfate crystals safely? So any suggestions? How can we get copper sulfate crystals safely? So you will describe the whole process, saying that we will warm the sulfuric acid, because sulfuric acid is a very strong acid. No, not just water bath. You will explain from the beginning, because you are using a very strong acid, which is sulfuric acid. So we will just warm it. Okay, remember, we will not boil it. We have to be very gentle with sulfuric acid because it is very strong, and then we will add copper oxide with the help of a spatula, very gradually, slowly, and we will keep stirring with the help of glass rod, because we will give time for the copper oxide to react with the sulfuric acid, and we will keep adding until the copper oxide stops disappearing and starts settling down at the bottom. Why? Why would we wait for the copper oxide to settle down at the bottom for us to stop adding? Why would we stop? Why are we waiting for the copper oxide to appear at the bottom? Yes? No? Yes, Wajiha. Yes. So that, because that is what will tell us that now all the copper oxide has reacted. That means neutralization reaction has completed. All the copper oxide has now reacted, and now no more is reacting. So when we are adding, instead of reacting, it is settling down at the bottom. Good job, Vijaya. Okay, then the next question is, how can they tell when the sulfuric acid has been neutralized? So we have already answered this question. When we start seeing copper oxide at the bottom. Okay, and yes, I forgot to continue that part, that after the copper oxide starts settling at the bottom, then we will filter out the solution. So in the filtrate, we will have copper sulfate as well as water, because all the copper oxide has reacted with all the sulfuric acid has been reacted, and the leftover has been separated with the help of filtration. So the residue on the filter paper will be our copper oxide, and in the filtrate we will have the copper sulfate. Okay, I hope you are looking at that picture as I'm speaking, that picture of making a salt. This is my video on? this one, this page, okay, this page. And so after filtration, in the filtrate, we have copper sulfate solution. And then with the help of water bath, we will gently warm it. Why? Because we don't want to destroy the crystals. Using a water bath for uniform, gradual, and gentle heating. And as soon as we start seeing the crystals, we will stop this heating and we will leave it for a day or two in a sunny, windy place, okay, near the window. Okay, this picture is even in your book, Riaz. This picture, if you can figure out what page this is, yeah, I am just showing you the same page. Okay, 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 it is page 200. Wajiha is saying it's page 200. Okay, now let's move on to the next question. This question, oh, what type of substance is the black copper oxide powder, an alkali or a base? Now who will answer this question? What type of a substance is copper oxide, an alkali or a base? Yes, base. Why? Why, Wajiha? What made you say that it's a base? Good job, Hassan. Yes, it's a base. What made you say that it's a base? Because it is not dissolving, remember? It is reacting, but then after all of it has reacted, it is settling down, right? So insoluble alkali is called a base. Good job. Okay. Part D, write a word equation and a symbol equation for the reaction. Yes, Hassan. Okay. Part D, write a word equation and a symbol equation for the reaction. Word equation is easy. What's the word equation? So word equation would be this, that copper, can you hold this camera for me? Copper 2 oxide. Now, why do we write copper 2 in parentheses in these brackets? 2 means that this is copper 2 plus, okay? Because it's a transition metal. Transition metals can have more than one type of charge. Like we have copper plus 1, we have copper 1 plus, we have copper 2 plus. So now which copper are you talking about? So therefore we mention the charge, you can, in brackets. So copper 2 oxide reacting with sulfuric acid. This is word equation. So I will use the names, okay, not the symbol. Symbol will be in the chemical equation. This is word equation. So copper 2 oxide plus sulfuric acid gave me copper 2 sulfate plus water. This is the word equation. Now my chemical equation would be copper 2 oxide. I know, I hope you guys know how to write symbols. Do you know how to write formulae? Not symbols, formulae. I hope you guys know how to write formulae. The oxidation state of copper comes here. Oxidation state, see, oxidation state of copper is +2. Oxidation state of oxygen is -2. So crisscross, can you please vertically above this? Yes. So yeah, zoom in. So oxidation state of oxygen will be written here, and oxidation state of copper will be written here. So copper 2O2, but when we have both, when both the numbers are same, they just get cancelled. So we get CuO. Okay, CuO, simple, because the 2 got cancelled. Again, sulfuric acid. Hydrogen has an oxidation state of plus. Sulfate has an oxidation state of -2. So 2 will be written here, 1 will be written here. So I got H2, and we don't write 1, so I will leave SO4 like that. So SO4 gave me copper 2 sulfate. Zoom out. Copper 2 sulfate. So copper has 2 plus, sulfate has 2 minus. 2 and 2 get cancelled, so I don't write anything. CuSO4. If you don't know how to write formulae, it's okay. I will do it with the basics in the basics class. Okay, and then you can. So this is my chemical equation. Now, copper oxide is insoluble, so solid state sulfuric acid is aqueous. Copper sulfate is soluble. Is it soluble? No, it's not soluble. No, it is. All the sulfates are soluble except for barium, calcium, and okay. Yeah, it is soluble. And then liquid. Yes. Okay. So state symbols are also very important. Your word equation, your chemical equation should have state symbols. No, Riaz, that's it. This is our last class. This is our last class. Okay, then my the next class that I will take will be after Eid. Yes. Okay. Next question. Okay, no. Next question. What other question at the end of chapter? At least I want to finish the end of chapter questions. Okay, Vani has a solution. Vani. Where did the Vani question go? Okay. Oh, time waste. Okay. Okay, I'm just using my camera. I cannot find it. This. Vani has a solution which she thinks might be acidic. Describe 3 tests she could do to see if it is acidic or not. What are the 3 tests you can do to see if a substance is acidic or not? What are the 3 tests? Yes, one is use of indicator. Very good. It can be universal indicator. It can be a litmus paper. Yes. No, but litmus paper and indicator will be considered as one answer. I mean, as like one way. Conducting electricity. Well, and a salt solution will also conduct electricity. So that is not a confirmation that this is acidic. Something that only acids do. No, heat change also can be done by other reactions as well, something that only acids do. If it will react with alkali or base. No, pH indicator is the same thing as indicator, universal indicator, pH meter would be the same thing. See, you will make it react with metal and see if there is hydrogen gas being produced, because only acids react with metals to give hydrogen. Okay, so you can add a metal into the solution and see if there are bubbles being formed, and if bubbles are being formed, then you will carry out the hydrogen identification test. Do you know the hydrogen identification test to verify if this gas being produced is hydrogen or not? Yes, the lighted splinter will give a pop sound. So you will not just write lighted splint, you will say there will be a pop sound with a lighted splinter. Right, there will be a pop sound with, you have to write the word pop sound with a lighted splinter. Yes, Hassan. Okay, so this is, one is indicator, second is the reaction with metals, and third is reaction with, use the reactions of acids. Carbonate, giving carbon dioxide. With carbonate, again, there will be fizzing, and then you will carry out an identification test for carbon dioxide. And what's the identification test for carbon dioxide? Anybody knows the identification test for carbon dioxide? Identification test for carbon dioxide. See, Hassan, fizzing will only tell you that there is gas being produced. How will you find out which gas? Okay, to find out what gas is being produced is very important, because they can be any gas. So what do we know? So for example, you have a substance, you don't know if it is acidic or not. You have to confirm if it is acidic or not. So you will use a metal, you will add some metal into it. Now it is fizzing, okay. But then to confirm that this gas is really hydrogen, you will bring a lighted splinter close to it. And if it gives you a pop sound, you know the gas is hydrogen. So again, in the same case, if you have a substance, you don't know if it is acidic or not, but you have a carbonate, for example, sodium carbonate. Now you add that carbonate, again, you see fizzing. But to confirm if this gas is really carbon dioxide, you will let it pass through lime water, right? Yes, thank you, Hassan. What about lime water? What will you see with lime water? What will you see with lime water? Yeah, it turns milky, right? So lime water turning milky is the identification test for carbon dioxide, okay? So these are the three methods you can verify if a substance is acidic or not. Then the last part to this question is explain why water is needed before a substance can show its acidic properties. Yes. Why is water needed for any substance to show its acidic properties? Come on, come on, come on. Because it is the hydrogen ions which are responsible for the acidic properties. Yeah, I mean, it is the hydrogen ions which are responsible for the acidic properties, and hydrogen ions will be released and will be available for reaction only when there is water, when the substance will dissolve in water. Okay? Okay. Now we have 4 minutes. Let's try to do further questions as much as we can. The question is about acids and alkalis. Copy and complete the following table. Color for universal indicator, red. The pH would be, give a guess. Oh, give a guess. The pH would be, yes, 1 or 2. Yes, Hassan, 1 or 2, because red is too dark. If it were pink, then you would have, like, you know, yeah, Hassan, saying lower than 7 is not enough. Okay, you have to be more specific. Can you see that in the table, in the table, they have given 11. So they expect you to write a number here, not lower than 7. Okay, you will write 1 or 2 or something like that. Green. Green. What number with green? 7. Good job, Hassan. Yes. No, you have to write number. You have to write number. Wajia, don't write neutral. Write a number here. Follow the pattern. They have written a number. Okay, what color here for 11? What color here for pH 11? Blue? Blue or purple? Are you sure it's yeah, okay, blue. Yeah, purple is 14. Yeah, okay. Okay. Then part B. The reaction between an acid and an alkali can be summarized as acid. Okay. Acid plus alkali giving salt and water. So name this type of reaction. Neutralization. Good job. Name the salt that would be formed by reacting dilute hydrochloric acid with potassium hydroxide. What I want others also to participate. Only 4 to 5 students are participating. That's it. And I don't like forcing those students who are not participating themselves. So you have to participate yourself. Okay. Yes. Why do we have potassium chloride? Is because this is hydrochloric acid plus potassium hydroxide. Can you please hold this for me? Okay. So insiders react together and the outsiders react together. So we get potassium chloride plus water. So potassium chloride would be the salt in this case. Okay. Name the acid and alkali needed to produce the salt sodium nitrate. Sodium nitrate. Yes. Sodium. What did Hassan say? Can I see? Nitric acid plus sodium. Yeah, you have to write the name of acid and alkali, Hassan. Acid and alkali. Okay, so you gave me metal and acid. You gave me metal and acid. And Wajiha, you gave me a salt and an acid. They are asking for acid and alkali. Acid and alkali. Now, first of all, write down the formula of the salt. What did they say? Salt, sodium nitrate. This is coming from, remember the anion comes from the acid. Anion comes from the acid, remember? And the metal comes from the alkali. The metal comes from the alkali. So this sodium would come from the alkali sodium hydroxide, okay? And nitrate can come from the acid nitric acid. So this can be our alkali and this can be our acid. Nitric acid with sodium hydroxide can give us sodium nitrate, right? Did you understand? Yes, okay. Let's move on. Question number 2. Claire made sodium chloride. Now, are you with me with the further questions? I'm doing further questions. Take out further questions. Okay. Okay. I'm here. So this we have done. Okay, this one. Claire made sodium chloride solution by adding sodium hydroxide solution and alkali to hydrochloric acid. What name is given to substances such as sodium chloride formed from the reaction of an acid with an alkali? This is easy. What is that product called which is produced? Salt, right, Wajiha, salt. Then part 2, name the process taking place in this reaction. Easy, it is, the process is called, yes, neutralization, yes. Okay, then what should Claire use to find out when she has added enough sodium hydroxide solution to react with all the hydrochloric acid? What can Claire use to find out when she has added enough sodium hydroxide solution to react with all the hydrochloric acid? Now, before you decide on the answer to this question, you have to ask yourself, are both the alkalis and acids soluble? Colorless solutions? Are they both soluble solutions and colorless? If they are, then what should, then that will affect, yes, universal indicator, okay? And now, if one of them was insoluble, then we could have waited for it to settle down at the bottom. Or if the product was a gas, we could have waited for the gas bubbles. Okay. Part 4, describe how she should use this to make sure she added the correct amount of sodium hydroxide. Describe how she should use this to make sure she added the correct amount of sodium hydroxide. So now she should be using what? Burette, and she should be adding drop by, first of all, she will add few drops. By few, I mean 2 to 3. Few drops of indicator meaning how many drops? 2 to 3 drops of indicator. And then you will add, she's adding what? She added the correct amount, yeah. Then she can add the sodium hydroxide drop by drop until, and she will keep swirling, keep observing the color change against sunlight or against a window. And when she sees the color change to green, exactly green, that's when she knows that now the solution is neutral and she should stop adding sodium hydroxide, right? Okay. Part B, sodium chloride can be separated from its solution by evaporation. Draw a label diagram to show how this is done. So what diagram will you make? You have to show evaporation of a salt. You have to show how you get a salt by evaporation. So yeah, I will tell you which diagram you are expected to draw. Same. This is the same experiment that we were discussing. This one, part 3, number 3. This is evaporation. Now remember, 1 mark for showing the source of heat, 1 mark for showing the tripod stand, 1 mark for showing the wire gauze, okay, marks for showing the evaporating basin, marks for showing the water bath, mark for labeling the copper or whatever your salt is, label that, label this as water bath, label this as tripod. All these will carry marks. So remember, your diagram should be this, okay? I made this diagram myself. Yes, marks for everything basically, yes. So I made this diagram. Check my diagram out. This is my diagram. See how I have labeled each and everything. Bunsen burner or a heat source. You can even draw an arrow and label it as heat source if you don't want to draw a Bunsen burner. But yes, tripod stand. Oh, I forgot to label the tripod stand, by the way. Yeah, you should label the tripod stand and the wire gauze. Okay, beaker. This is my beaker. And this is the water bath. And then the steam is coming out. Okay, and there's this evaporating dish and salt solution. Okay, this is your diagram. Okay. Let me go back to the questions. Okay, this question is done. Okay, part C. Milk of magnesia can cure indigestion. Explain how milk of magnesia works. How milk of magnesia works. How, yeah, it's an alkali. It's an alkali, and so it neutralizes the acid. Yeah, it neutralizes the acid, okay? Okay, the time is over. It's 5:07. So I am so sorry. I could not do all the further questions I wanted to do. So, okay, now see you, inshallah, after Eid. And then we will decide what to study after Eid, okay? Go on. Should I finish the further questions at least? It might take half an hour. It might take half an hour. So, okay, those who want to stay with me and want to finish these further questions can stay with me, and whoever, because you know, these are voluntary classes. I'm not marking anybody's attendance. You are not being marked on your attendance or anything. So you can leave if you want, okay? So let me finish the further questions with those students who want to finish. Okay, so can we take out the further questions back? Yes, hydroxide ions will conduct electricity because they are charged particles and they are mobile, right? Because today is my last class and I do not have time. I mean, I don't have an extra class to finish this off. Therefore, I'm trying to finish this off, okay? Okay, question number 3. Sodium carbonate reacts with acid. Complete the word equation. So sodium carbonate reacting with hydrochloric acid to give sodium chloride, dash, and water. What will be the dash? What will be the dash? Sodium carbonate reacting with hydrochloric acid to give sodium chloride plus dash and water. Yes. Yes. Come on. Yes, carbon dioxide. Hassan, you can leave if you want. It's okay. You can listen to the recording. It's okay. Name the salt produced if sodium carbonate reacts with dilute nitric acid. Sodium carbonate reacts with nitric acid. Now, first, let me share my video with you. Okay, I am sharing my video with you. So this, can you take out the further questions? What was the salt? Name the salt produced if sodium carbonate reacts with dilute nitric acid. Sodium carbonate reacts with dilute nitric acid. Now, of course, the acid will give the anion, right? So we have nitrate from nitric acid and then metal from the carbonate. So sodium nitrate, and nitrate has -1 charge and sodium has +1. So +1, -1 get canceled out. So we don't write anything. Sodium nitrate, carbon dioxide, and water, right? Okay, question number 4. An acid and an alkali react together to form a salt. These reactions are always exothermic. What does exothermic mean? mean? I just discussed with you. What does exothermic mean? Exothermic mean a reaction, right? Good job, Wajiha. You're learning very fast. Mashallah, mashallah. Yes, exothermic means when heat is being released. Okay, a reaction that releases more heat than what can be absorbed, right? Okay, what name is given to the reaction between an acid and an alkali? This is so easy. Neutralization, right? Let's move on. What substance other than a salt is always formed when an acid reacts with an alkali? Other than a salt is water. In fact, the ionic equation for neutralization reaction is ionic equation for neutralization reaction. Never forget this. This is the ionic equation for the neutralization reaction, irrespective of what acid you're using, irrespective of what alkali you're using. This is the ionic equation for a neutralization reaction. Don't let them trick you. Copy and complete the following table to show the salt formed on mixing the alkali and the acid. So let's fill up this table. What will react with a nitric acid to form sodium nitrate? So can I have a pencil? Can I have a pencil? I just brought a pencil here. Yeah, here. Okay. So this is the cation, right, of the salt. The cation comes from the alkali. So yes, to show the salt forming on mixing the alkali and the acid, and it has to be alkali. So you cannot just write sodium here. This has to be alkali. So you will write sodium hydroxide. Okay. Barium hydroxide reacting with hydrochloric acid. So anion will come from the acid and the cation will come from the alkali. So barium chloride. And you know we use the suffix "ide" when a compound of two elements is formed, barium chloride. Then potassium sulphate. Right. So this anion will come from the sulfuric acid and this cation will come from potassium hydroxide, which is the alkali. So I will write potassium hydroxide and here I can write sulfuric acid. Okay. Part C, describe how you could prepare a solution of magnesium chloride starting with dilute hydrochloric acid. Include in your answer what you would do, what you would see, and how you would make sure that all the hydrochloric acid had been used up. So basically you have to explain the whole process. Starting from the scratch, you will explain the whole process of how you prepared. Yes, whoever wants to leave can leave. I have already mentioned that. I have already. Okay. Magnesium chloride, right? Magnesium chloride came from starting with dilute hydrochloric acid. Okay, I've prepared a solution of magnesium chloride starting with dilute hydrochloric acid. Prepare a solution of magnesium chloride starting with dilute hydrochloric acid. Include in your answer what you would do, what you would see, and how you would make sure that all the hydrochloride has been used up. So what are the 3 ways you can make this magnesium chloride? You can use an alkali, you can use a metal. Metal would be of magnesium, and you can also use a carbonate. Remember, these are the 3 reactions we have studied to make a salt. We can use alkali, we can use metal, we can use carbonate, right? So let's suppose, which one do you want me to do? Which one do you want me to do? Alkali, metal? Yes, metal is easier. Yes, Hassan, metal is easier because we can follow it by observing the bubbles. We can wait for the fizzing to stop. Okay. The other way is when the metal will start settling at the bottom. So then we know that the neutralization reaction has completed, right? So yes, so let's do a metal. So we will keep adding. So we will take a known volume of hydrochloric acid, let's suppose 25 cm cube, in a beaker or a conical flask. And then with the help of a spatula, we will gradually add metal and we will keep stirring with the help of a glass rod. And we'll wait for the metal to disappear. And also we will observe the fizzing, the bubbles. Okay. And with the help of a lighted splinter, we can even confirm if the gas is hydrogen. And we will keep adding until the metal starts settling at the bottom or when the bubbles stop forming. Then we know that all the acid has now reacted, right? And we can filter off the excess of metal. The filtrate will, our filtrate will have magnesium chloride along with water. So let's write down the equation here. Okay, this is solid, this is aqueous, this again is aqueous, and this is liquid. And then you can balance it by writing 2 here, because there are 2 chlorine atoms and 2 hydrogen, so 2 HCl will balance this equation, right? And then at the end you will explain the process of evaporation using a water bath, right? And you will stop heating as soon as you see crystals and all of that. Okay, let's move on. Complete the following word equations. Zinc plus sulfuric acid. Zinc plus sulfuric acid would give us what? So acid will give us the anion, and metal will form the cation, right? So we will get zinc sulfate plus hydrogen gas, because there's hydrogen. So metal reacts with acid to give salt and hydrogen. Then sodium hydroxide reacting with nitric acid will give us what? Sodium nitrate and water, right? And you can write this in the word form, right? Sodium nitrate and water. Then we have magnesium carbonate reacting with hydrochloric acid. And then what will we get? Yes, magnesium chloride. Good job, Hassan and Wajia. I appreciate your patience with me as well as your participation, right? So this is gas, liquid, and this is an aqueous salt, right? Now let's move on to question number 6. Yes. A student made a sample of zinc sulfate crystals. She added excess zinc metal to acid and warmed the mixture. When the reaction was finished, she filtered the mixture. She left the solution to allow crystals to form. Name the acid she used. So what salt was she trying to make? Sulfate. To make a sulfate, what acid should you be using? Should she be using to make sulfate? Sulfuric acid. Yes, Wajiha and Hassan. Good job. Yes, good job. Name the gas formed by the reaction. So metal with acid, what gas is being produced? Hydrogen. Don't forget to write the 2 at the end, Wajiha. H2, because hydrogen is diatomic molecule. So you will write H2. Good job. Then, why did she use excess zinc metal? Why did she use excess zinc metal? Any? No. Why did we use excess zinc metal? Okay, Hassan, we will recap. Let me finish with the questions. Yes, Wajiha, to make sure that the reaction has completed, that all the acid has reacted. She used excess of zinc metal to make sure that all the acid has reacted. Yes. Why did she warm the mixture? Why do you warm? Yes, to increase the rate of reaction. Yes, perfect. Why did she filter the mixture? Why did she filter the mixture? Yes, to remove the excess of zinc, because we want pure salt, isolated pure salt. We don't want any contamination. We don't want anything else to mix with it. Okay, this is the second last question. Yes, this is the second last question. The diagrams show what happens when an acid is added to an alkali, right? This is a beaker which contains dilute hydrochloric acid, and this flask contains dilute sodium hydroxide, and some drops of universal indicator is already added, and it is purple in color. Why is it purple in color? Because it is added into sodium hydroxide, which is highly alkaline. So pH is 15, pH is 14. Now in stage 2, we added this. Gradually, dilute hydrochloric acid is added to the flask and mixed. Now indicator turns green. You don't have this question? Oh, okay. Okay, just follow with me then. Follow with me then. I think this question is in the old book. Okay, so indicator turns green. What is present in the flask at stage 2 besides universal indicator and water? So you had dilute hydrochloric acid, you add it into sodium hydroxide, okay? So what will you get? What will you get? Yes, you, Hassan, good job. So sodium from the alkali and chloride from the acid. So sodium, chloride. Good job, Hassan. And I hope Wajia also knows this. Write an ionic equation to show how water is formed in this reaction and state the sources of the ions. Can any of you write the ionic equation for this reaction? And this reaction is neutralization, right? This is neutralization reaction. So can you write the ionic equation? I just wrote it down for you, remember? Yes, yes, Hassan, yes. Hydrogen ions reacting with hydroxide ions to give water, simple. Okay, and hydrogen ion sources, hydrochloric acid, because they have asked you to state the sources of the ions. So hydrogen ions come from the hydrochloric acid and hydroxide ions come from sodium hydroxide, right? Give the symbol for the ion which is produced when any acid, any alkali dissolves in water. So this is easy. Acid, what ion? What ion for acid? Come on, come on, come on. Hydrogen ions, right. Then for hydroxide, hydroxide, right. For hydroxide, for alkali, hydroxide, right. Copy and complete the following word equation. Calcium carbonate reacting with hydrochloric acid to give calcium carbonate to give, there are 3 products. You keep solving questions like that, you will get good at it, right? Calcium chloride, water, very good, Hassan. And third is, what's the third product? Remember, it's carbonate, carbon dioxide, right? Carbon dioxide, Wajiha. Okay, so with this, we have come to the end of further questions. Okay, Jazakallahu khairan for bearing with me. If there are any extra questions and you want to solve them and you cannot, my doors are open. You can contact me privately, WhatsApp, and I can, explain you. Okay? Okay. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh. Is there any question? If there is any question, you can ask me right now.
I don't think I don't think any of us have a question.
Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.